Welcome back to our Security Plus SY-0701 course. In today's lesson, we'll compare and contrast the security implications of different architecture models. Let's explore various architecture models and their security implications. Cloud computing. Cloud computing offers scalable resources over the internet. It comes in several models, each with unique security considerations. Responsibility matrix. In cloud environments, security responsibilities are shared between the cloud service provider and the customer. The responsibility matrix outlines who is responsible for what aspects of security. Hybrid considerations. A hybrid cloud combines on-premises infrastructure with cloud services. Security implications include managing data flow between environments, ensuring consistent security policies, and protecting data in transit. Infrastructure as code. Infrastructure as code automates the provisioning and management of infrastructure using code and scripts. While infrastructure as code improves efficiency, it introduces security considerations such as code vulnerabilities, unauthorized access to scripts, and potential misconfiguration. Serverless computing. Serverless computing allows developers to run code without managing the underlying infrastructure. Security implications include reliance on the provider for infrastructure security, potential vulnerabilities in application code, and event-triggered functions that may expose sensitive data. Microservices. Microservices architecture breaks applications into small, independent services. While it enhances scalability and flexibility, it introduces security challenges such as securing communication between services, managing numerous endpoints, and handling distributed data. On-premises. On-premises architecture involves hosting infrastructure and applications within the organization's facilities. While organizations have complete control, they must invest in robust security measures, including access controls, intrusion detection systems, and regular patching. Centralized architecture. In centralized systems, data and resources are located in a single location. Security advantages include easier management and enforcement of security policies. However, it creates a single point of failure and may be more vulnerable to targeted attacks. Decentralized architecture. Decentralized systems distribute data and resources across multiple locations. This reduces the risk of total system compromise, but introduces challenges in consistent security policy enforcement and increased attack surfaces. Containerization. Containerization packages applications and their dependencies into isolated units called containers. Security considerations include isolating containers to prevent breaches from spreading, securing container images, and managing vulnerabilities in containerized applications. Virtualization. Virtualization allows multiple virtual machines to run on a single physical host. Security implications involve securing the hypervisor, preventing VM escape attacks where a compromised VM affects others, and managing resource isolation. Internet of Things, IoT. IoT devices are interconnected objects with embedded sensors and network connectivity. Security challenges include limited device resources for security features, lack of standardization, and widespread deployment increasing the attack surface. In this lesson, we've compared and contrasted the security implications of different architecture models, including cloud computing, serverless, microservices, and more. Thank you for joining us, and see you in the next lesson.